Hello, happy August. Welcome to the Central Ohio.NET Developers Group, or CONDG. It's not corn dog, as I've heard it pronounced in the community. I don't know where we got that rumor, but it's fake news. Today we were talking about, this is actually our third to last meeting of the year, believe it or not, but we were talking about agentic workflows with Azure Functions, and Michael Collier, he's here. He gave a nice lightning talk last month, and following it up with a full talk. So really excited about that. Some basic logistics, if you're finding us on YouTube or you came here because you work here or a friend brought you here, we are on Meetup. It's a good way of finding out about our future events and the like. So you can check that out there. We meet the fourth Thursday of the month until October, because November and December are typically holidays, fourth Thursdays of the month. Organizing team is Alan, myself, and Sam. So we're happy to be here. If you want to help out with us in any way, we always appreciate help. We always appreciate new speakers. We do have a YouTube channel with over 338.9 subscribers as of an hour ago, so you can kind of infer the probable number from that. But it's a good way of finding new things. By the way, next month, we are not going to be on YouTube, very likely. So just a heads up there if you're watching online. So we'll talk more about that. We do have a Discord group, which is awesome. So that QR code here will take you to that. It's a good place to just talk about random things that are interesting to you and ask questions and all that good stuff. We are on socials. We don't post on socials, but we are on socials, technically speaking. So if you care about that, cool. You can find us there. And we do want to thank Central Insurance in particular for hosting and providing a mountain of tasty pizza, which I'm going to have more of here in a second. As well as .NET Foundation for paying our dues on Meetup, which is something that all user groups have to kind of deal with, and JetBrains for free licenses as well. By the way, for those here in person, raise your hand if you are interested in a JetBrains license this month. Okay, I see 2 hands. I have 2 licenses, so I will talk to you 2 at the end today. So hot dog. Like I mentioned, we have a couple more meetings this year. September 25th, we're still trying to figure out what we're doing. October 23rd, we will be talking most likely about what's new in .NET 10. We don't have a speaker for either of those yet, so if you'd like to talk about that, if you know somebody who's interesting and has something ready to talk about, hook us up with them, because we'd love to have some content there. Otherwise, it'll be me talking about automating my dog or some crazy thing like that, and nobody wants that, and police often get involved. So things to avoid there. We have a few more days left in the call for presenters or call for speakers for the CodeMash conference next January. Sam, why don't you tell me a little bit about CodeMash? What is that?
For those of you that don't know that, is a super fun conference in 13th to the 16th of January. The conference is at a water park, so it's very family oriented. A lot of people, speakers and attendees, bring their families. There's a lot of activities for kids. We have a mini conference called Kids Smash, which is just kids sessions, trying to get interest in technology. Workshops, we have half-a-day workshops. We have regular sessions, so super fun, really good event. So if you haven't been to CodeMash, keep an eye out for tickets. And if you're interested in speaking, you have 3-4 days until CFP is closed.
Yeah, ends at midnight on the 31st.
Yep.
If you need help with your abstracts, there's people there who will help you with them, but people here would love to give you feedback as well. Yep. Always trying to get new speakers, and otherwise they get me talking about my dog, and nobody likes that. Who here is hiring? Okay, so we got Alan at Improving. Improving's looking for senior everything?
Pretty much.
Senior everything, okay. So talk to Alan. Leading Edge does occasionally have some roles. I'm not sure we have anything at the moment, but we are often looking for new things. So if you have a diverse skill set or interest, just chat with me later, and we'd love to chat with you too. Central has some great stuff here. If you're looking for the bathroom, it's over that way. And if you work here at Central, raise your hand. One of these nice folks can help you with that. Figuring out where to go. On that note, I'm going to censor myself. I'm going to turn things over to Michael, who's going to do a much better job than I am. And we're really looking forward to this. So, Michael, thank you for speaking this month. Yeah.
So I need the cable,
You
right?
need the cable.
All right.
And I am going to... I think you need to share yourself. I can't make you share.
You can't make me share.
I can't make you share.
Seems so limiting.
Well, it looks like you're good, so I'll get you out of here.
Awesome, thank you. All right, good, Alan?
Yep.
All right. Let's see if this works. Fantastic.
No,
it's-
you can't.
No?
I don't like that.
How is that working? Does it not do?
Yeah, you can't do the presenter view.
Really?
Yeah.
Okay then.
Yeah, it's obnoxious.
I have to get it back. So I have to reshare.
There you go.
Now I need to disable presenter view somehow.
Boot out again, isn't it?
How do you get out of presenter view when you have an external monitor?
Yeah, but duplicate your screen instead of sharing.
Go to slideshow.
Extending.
Should be a.
Use presenter view.
Yeah. There's somewhere in there.
And you have to stop and share again. The technology works. It's really good.
I'll put that on.
Hey.
Okay, we'll see if I remember what I was going to talk about now.
Yeah.
All right, well, welcome everybody to the talk I'm going to put together here. I've been putting together for the last few months on building agentic workflows with Azure Functions and friends. My name is Michael Collier. I am a husband of one, that'd be weird, husband of one, father of two, an avid Buckeye fan, very much looking forward to the game on Saturday, a bad golfer, and okay at barbecuing, and I love Mustangs. And during the day, I'm a principal architect at Centric Consulting. If you want to get a hold of me, you can snap that QR code. I'll take you to my blog, and all my contact information is there. So things we're going to be talking about tonight is a little bit on agents and workflows, and then how I kind of think about putting all these stuff together. And then I'm going through, I'm kind of built like friends with this .NET Aspire, Semantic Kernel, durable functions, and the durable task scheduler, which I talked about last month at the Lightning talk. So let's talk a little bit about building, kind of what are like agents and workflows and how some of this new technology can work together. And one of the things I've been thinking a lot about lately is kind of how do you compose these kind of more intelligent systems, these AI workflows. And Anthropic, I think, did a really nice job a while ago putting together a paper that's linked here at the bottom of the slides on defining what are workflows and agents. And they kind of define it as workflows as being where LLMs and tools are orchestrated through predefined code paths, right? So I'm writing code and then kind of helping orchestrate the calling of the LLMs in that way. Whereas agents are a little more open-ended, right? I got the LLMs and they determine how they want to solve the problem, the flow they want to take, the tools they want to use, and they really maintain more control over the process that gets rendered. So it's a little more for these open-ended sort of tasks. And I think there are a lot of cases, though, where problems that we deal with at a lot of businesses aren't as open-ended, right? Where when we start thinking about building agentic systems, agentic workflows, there's a predefined sequence of events that have to happen. Businesses that have spent a lot of time putting together their workflows, they know the processes that have to be there, but we need to figure out how do I incorporate AI agents and LLMs into those existing workflows. And so I think then the question becomes a lot of times of, do you need a multi-agent solution, right? There's a lot of buzz in the industry right now around multi-agent solutions and how do you incorporate that? And I think sometimes the answer is certainly yes. When I have more of an open-ended problem I want to solve, I'm not really sure what the path is. I'm not sure kind of how to go about solving that. Putting a bunch of agents out, maybe I'm doing big database migrations or a big document analysis. I need to have these agents working together. I think that system can work really, really well. It's a great case for that. But it is kind of a challenge then on, if I have more of a linear or workflow is kind of well-defined, do I really need a multi-agent solution for that? Because it does introduce problems around reliability, observability, and so forth in that sort of solution. I think you can get to a good place when you're building these agentic workflows, especially when you're looking for more reliable and more efficient sort of outcomes in there. When I have known cloud native technologies to work with, I have some code-based workflows. Maybe it's durable functions, or maybe kind of the logic apps can do that same sort of idea, these workflow systems. And I think this is where durable functions can come in really handy when you're trying to build these agentic workflows, right? I know from the functions platform in Azure, I get the resiliency that if a compute instance fails, the platform is going to spin it back up for me automatically. I have built-in observability with App Insights as a first-class sort of tool within the functions platform. And I can externalize that state that is so often the hardest part from a resiliency perspective with either Azure Storage or the new durable task scheduler service as well. So I can make sure my compute comes up and is resilient, and I can rehydrate all my state from a very persistent state store and storage or task scheduler. And this gives me that deterministic then workflow as well, because I know in code I've laid out what is my workflow, what are the sequence of events, what branching logic do I have, and I've got control over that. And then I just need to figure out how do I want agents to play in that space. So let's talk a little bit about kind of putting this stuff together. When I was kind of coming up on this area, I like to solve problems or come up with a problem that I want to solve to work through the technology. I need something to kind of help me figure out how do I want to incorporate all these different scenarios together. And the idea I came up with is a contrived insurance claims processing solution, where there's a definite sequence of events that have to occur to process an insurance claim. It's a pretty linear sequence of events. It's very well known and laid out long ahead of time. So in my scenario, I've been thinking through, okay, I get an insurance claim that comes in. I need to check, do we have all the data for that claim? Is all the required fields there? Then I might need to turn that into a canonical form, something that downstream systems can rely on and know that that form is going to be persistent. So I want to kind of do some data manipulation there. I need to look up then to see, is this particular policy covered? So I need to maybe pull up some sort of repository or go look at a file somewhere and kind of analyze that file and say, okay, is this claim covered under this person's policy? I might have an existing API that can tell me all about that customer's claim history. What have they submitted in the past? So I want to be able to leverage that existing tools that I already have. And I need to make a determination based off of the current claim they've submitted and their history. Is it likely this is a fraudulent claim, or at least a high probability of a fraudulent claim? And if it is, send it to a human for further analysis. And then I need to generate a report. I write down kind of all the information that we took in and persist that somewhere so that another system could pick that up. And maybe generate some communications and send that out to the customer as well. So to put all this together, I kind of put together these friends that I'm really excited about, this technology that I think is a really fun space to play in. One is .NET Aspire, right? This gives us an orchestration and local development experience. We'll look at that here in a minute. And then figuring out Azure OpenAI for the agentic capabilities, Semantic Kernel tapping into that to give us an enterprise-grade SDK for building agents, Model Context Protocol or MCP, so some way that I can have these agents talk to my existing APIs that I have, and then using durable functions as that orchestration layer to help lay out what's going to happen, how's it going to flow, and then durable task scheduler to give me this managed back-end service and also some visibility into my workflow as well. So we'll talk about all of these. So if you're not familiar, .NET Aspire is kind of where we're going to start tonight. .NET Aspire is really Microsoft's kind of opinionated stack for building modern cloud native applications, right? The nice things about Aspire is it gives you as a developer a very easy local development experience to get up and running, right? It can handle automatic resource provisioning for you. If I've got containers or Azure services, it'll provision all that information for me. If I'm running locally, I can have emulators. Maybe it's a container that I want to run or the Azure storage emulator. I can spin all that stuff up as well and determine if I'm running locally or in the cloud, do I use the emulator or the actual Azure service? One of the nice things I think about Aspire as well is it has a standard way of managing configuration. Like so often if I'm building, having a solution that has multiple projects, I've got multiple configuration files I have to deal with, multiple JSON files or whatever, different formats for that. I've got to then figure out how do I want to spin up all these different services. Is it a Docker Compose? Is it multiple terminals running shell scripts to get it up and running? I find that just annoying, and Aspire makes that just so much easier because it has one way, one place in C# code that manages all that, and then a pattern to disseminate that information to any of the other dependent services. So it really does eliminate that works on my machine problem that is so often kind of be a sticking point for teams, right? If I have my code in my Azure DevOps repo or GitHub, I can give it to a teammate. They can pull down that code. Maybe I just have to give them some information about which connection strings to use to those resources, those secrets. But after that, they're golden. They can just F5, deploy, and they're up and running. They don't have to worry about anything else. It becomes a very nice development experience. If I do want to deploy to Azure, it's an easy deployment process as well, because Aspire gives you that deployment path. It's all managed in code and has a model that will deploy either via Bicep or Terraform into Azure. And you get the Aspire dashboard as well, right? The dashboard we'll see here in a minute gives you that way to visualize all these different resources and all your observability in one spot as well. So this is a view of on the right-hand side here, the Aspire app host file. This is what coordinates all the different work you have within Aspire, laying out if I'm looking at Azure storage, am I want to run the emulator? How's the emulator run? Excuse me. And what Azure services am I using? Am I leveraging existing Azure resources? Like maybe an Azure OpenAI instance is already provisioned. I just need to know how do I get to that resource and make sure it's there. If I have multiple projects in my solution, make sure those projects get turned on as well. So if I want to stand up at maybe an ASP.NET project, which is this policy API you see on the screen, and my Azure Function project, make sure all those get stood up. And then from my Azure Function project, there's some dependencies on it. I need to make sure that Azure Storage is available. I need to make sure that I've got references to my Azure OpenAI instance in this policy API. So make sure all that stuff gets stood up. So this is a way that I can kind of tell that functions project, here's all your dependencies and all your configuration, and it's put in code, which is fantastic. And then for me here, I'm running the durable task scheduler as well. The durable task scheduler can be an expensive service to run just for development reasons, for development purposes. So I'm spinning up the emulator as well. So I can spin up any container I want with Aspire as well, and tell it just to go ahead and manage all that for me. And it keeps all my stuff in one spot, which I think is the fantastic part. I got one place in C# code that manages everything for me, and I can have the dependencies on those projects to just kind of move the configuration around, or pass the configuration around, excuse me. This is the Aspire dashboard. We'll see that here in a minute as well. This gives me that view into all my different Azure services, any of the configuration or parameters that I have. And you can see on the left-hand side, if I want to see console logs for any of those different services, traces, metrics, any of that stuff, it's all in one spot. So as a developer, this gives you that kind of single resource to go to and say, how do all my services come up? What's the logs on those? How do I manage all that stuff? What's the configuration for them all in one single spot? All right, let's take a look at spinning up an Aspire project. All right, so this is a slightly more expanded version of what we had in the PowerPoint before. But for me, all my configuration is in this app settings.development.json file. These are the only secrets that I have. If you look at my Azure Function project here, there's no local host file. Oops, there's no local host, local.settings.json file. There's none of that sort of stuff there. I don't have any other app settings in any other project. There's one place that manages everything. And then in my app host file, I'm just reading in those configuration values, and I can use them later on in my project in this app host file as well. So I want to run Azure Storage. I can spin up the Azure Storage emulator, giving it some ports to connect to. I define the ports here because Aspire assigns random ports each time. So I'm predefining those ports. So if I want to connect to it with the Azure Storage Explorer, I've got a known endpoint to connect to. So that I want to use Azure Blob Tables and Queues. I've got an existing Azure OpenAI service, so all I need to connect to that is knowing what is the name of that service and what resource group is it in. And I can go ahead and get the connection string, the endpoint for that. The Aspire integration provides that automatically. If I have connection strings to other services and I want those, I can leverage those as well. If there's not an integration, like there's not one for the Azure Communication Service, all I need is a connection string there. And then I've got two projects I'm working with. I'm calling it the Policy API, which is just a regular ASP.NET API project. That's sitting, where's that guy? Down here, just a regular ASP.NET project. And I got my Durable Functions project as well. And it requires things like Azure Storage. I want to make sure it passes that along. References to my API project and all my different dependencies. And then some environment variables that I know I'm going to need as well. So a lot of times these environment variables would be set up in your local.settings.json, but those are just environment variables anyway, so I can pass those through in the model. And then I'm saying if I'm in run mode, which is kind of in development here, I want to spin up this DTS container. So to get it going, that's really all you need is the app post file, and is the main sort of entry point for an Aspire project. So I can run it just so you can kind of see kind of how this spins up. And it'll kind of coordinate, or it'll orchestrate all the setup for me, which is nice. And it'll pop up here a dashboard for the Aspire dashboard. And I can see here, let's make this a little bigger, all the different resources that came up, the connections to them all. If I want to look at like my functions project here, and I view the details on this one, I can see all the different environment variables that get injected in for me, whether it's Azure Storage, there's Azure Web Job Storage that if you use functions you're familiar with. I can kind of click on it to see what does that actual value look like, right? Just the local storage. But any of my different endpoints as well, like the durable task scheduler connection string is in here as well. So it spins up all this stuff and some OTel stuff for me as well. So it manages all that, which is nice. And I can go in and look at, what are the traces for the different services. If I want to filter down to just a couple, I can do that as well. These structured logs would be in here, and you get filtering on all that, which is really nice. So I love this from that development perspective. Very easy, spin all your stuff up in one spot to manage everything. And I'll build off of this coming up. Any questions on the Aspire part of that?
Have you gotten any usage out of the AI features? I know that they added some AI capabilities to Aspire recently. Somewhat recently.
Can you expand on that? Like, I know they have like Azure, like OpenAI client. They added like Azure AI Foundry was a new integration.
If you go back to the to Aspire.
Oh, I stopped the service, but
okay.
I know they added there's like
Copilot.
the Copilot one. Yeah. I found that it's okay. It picks up some things, and it's some it didn't pick up when I asked it questions. It said it's not there, and I'm like, I don't think you're right. But yeah, I knew that was a new ad. Yeah. I think in 9.4 maybe. Yeah.
So when you see this in the wild at companies for .NET Aspire, do you usually see it in a monorepo style where all of their .NET Aspire stuff is in one repository, or do they do multi-project structure? Like, how does that scale as you're creating bigger projects?
From my experience, I've seen it in one because of the way the project references are set up. I don't know a ton about like trying to put it across repos and how that project, you might have built like containers or something. I don't know a ton on that. I've seen it mostly as one.
Containers are what we've seen. Okay.
All right, excellent. Thank you. If I remember not to hit the button. All right, so let's move on to Semantic Kernel, right? So if you're not familiar with Semantic Kernel is Microsoft's enterprise-grade SDK for building AI agents and solutions, right? They have a couple other ones like Microsoft extensions for AI, but Semantic Kernel is definitely their enterprise-grade SDK. You'll kind of follow the news. They are kind of merging some of the stuff with AutoGen into Semantic Kernel. There'll be a Semantic Kernel V2 it's coming, but they're kind of merging some of their stuff together to make it mostly all kind of centered around Semantic Kernel. And there are SDKs available for most of the popular languages, whether it's .NET, Java, or Python. The nice thing about Semantic Kernel is it works with pretty much any LLM. It's not just an Azure thing, so they can work with a lot of different LLMs that are out there. It supports multiple different models, so you can have multiple models within the same kernel and switch between them, and I'll try to show you some of that. And you have prompt templates, which I think is fun. I'll try to remember to show an example of that as well, right? So I can have my instructions, my prompts in code if I wanted, but as they get bigger, more verbose, it might be nice to externalize that into a file, maybe like a liquid file or a YAML file or something like that, where I can have them out on my application code. They have a new agent framework as well within Semantic Kernel. They got, I think, 5 different types of agents that you can work with. I'm going to be focusing mostly on the chat completion agent, but they have ones for OpenAI assistants, the new OpenAI responses. If you're using Azure AI Foundry, they've got agents that work with that as well. One of the nice things I think about Semantic Kernel is its ability to have tools or plugins if I want to run native code. So if I have code that I want to run some C# logic on, I can have it give it a tool or a plugin, give that to the kernel, and then the kernel will go ahead and call that tool and pass the information to the LLM, passing the output from that tool in there. So I can still run that locally. And if I need to connect to an MCP server, remote MCP server, I can do that as well, making that as a remote plugin here. Setting up the kernel is relatively straightforward. You create the kernel, and then in my case, it's giving it an Azure chat completion resource. And here I give it a deployment name, which is my model name that I want to work with. If I can have multiple models, and they segregate that out by services, so I can give it a service ID. It doesn't have to be the same as the deployment name or the model name. I just did that because it keeps it easier in my head, but you can call it pretty much anything you want. And then a reference to the client. In this case, I'm pulling in the client from the Aspire integration. If you remember, my Aspire app host had a connection, a reference to my Azure OpenAI instance. So I'm just passing that client through. So Aspire kind of provisions it out, and then dependency injection pulls that in for me, which makes it pretty nice. If I have any of those tools or plugins, it's simply saying that plugins.add from type and giving it that class name for the tool we want to pull in. And then go ahead and build that. That sets up the kernel. And then the agent itself is, again, relatively straightforward to set up the agent. In this case, I'm giving it a chat completion agent, the name of that agent, and then some instructions. The instructions are my system prompt. This is a obviously very simple one. I'll show you some longer ones here in a little bit. And then some arguments that might go into that, which is, again, the service ID. So if I wanted to switch between different services, I think if I had, what was the past one? I could have GPT-4.1 here, but maybe I want to override that and use GPT-4o mini. So I got multiple different models. Depending on what agent I have, they can switch between them. I can control what the response format should be. In this case, I'm trying to direct the agent to return JSON structure, which is sometimes successful, sometimes not, although most of the time it's been successful lately for me. And then I want it to go ahead and call any of the tools that it has access to, go ahead and call them automatically. So I don't have to tell it which ones to call, but it'll go ahead and invoke the tools that it thinks is the right one based off the description of those tools. Then I need to give it a message, so a chat message content. This is my user message. This is like what the user is trying to convey. Or is it asking the agent? And then I simply invoke that agent and then wait for a response to come back and grab that response back. And that is the basics of having a chat completion agent. And we'll go through some of that here in a little bit as well. So that gives us the agentic part of our agentic workflows. Durable functions is the workflow part of our agentic workflows. If you're not familiar with durable functions is really an extension of Microsoft's Azure Functions, and it really lets you to write stateful workflows in a serverless environment, right? I control in code how this workflow is run. There's two big pieces to durable functions. One is the orchestrator. The orchestrator lays out how my flow is going to be. It controls my flow. It is the code I write and say, I want to do this, and then this, and then this. If I can, any error handling, any logic, conditional logic could be in there. Activity functions are where the actual work takes place. Right, so I have an orchestrator. That orchestrator is then going to invoke activity functions to actually do the work. The nice thing about durable functions is it does provide that built-in state management. So I don't have to control how or when do I kind of checkpoint into Azure storage or write to queues. It does all that for me through the programming model. So I can use Azure Storage as the typical one most people use. I'm using the durable task scheduler because I want that the visibility I get with that in its sequence diagrams and monitoring tools. But all that checkpointing and resiliency and restarts is all managed through the programming model, which is nice. And that makes it much easier if you want to run any long-running workflows, maybe like these sort of agentic workflows where they can run for a period of time, data processing pipelines. If I need to pause the workflow, suspend it, resume it, that all gets handled from the programming model. And depending on what you're doing, there are multiple different patterns that you can run here. Like I'm going to show, I'm using the fan-out, fan-in pattern, function chaining, and human interaction. Human interaction would be like I need to pause the workflow for a period of time until some external event happens. Maybe I'm sending an email to someone and they respond, or there's a Teams message that gets posted, but some external event then kicks back a response that says, go ahead and continue processing. So the idea, again, with durable functions, there's something that initiates the function. There's a function trigger. Maybe it's an HTTP request. Maybe it is a message on a queue. It's a timer. Some event occurs that triggers this workflow. That workflow is going to schedule an orchestration. And then that orchestration trigger picks up on that scheduling event and then invokes a series of activity functions. And that becomes your entire workflow. So from a code perspective, this is your main part to durable functions. This is an HTTP trigger here. If I want, I can do any sort of logic in here. But the main piece is this schedule new orchestration instance async. In this case, we're going to start a new claim orchestration. So it's going to kick off that new claim orchestrator. Our claim orchestrator here gets triggered, And this just is going to lay out these activity functions that I want. This one just shows one, but I'll show you when I get into the other demo. I can have multiples of them with different branching logic, whatever you want at that point. But it is really just a series of calling activity functions and then letting them do their job in there. These activity functions can be whatever you want it to be. But it's writing to Azure storage, calling other APIs. In this case, it's going to be invoking our agent. I've got different activity functions. Each one of them has an agent that they can invoke to do different work, and they look, almost all of them, about like what you see here, because most of the logic is sitting in the agent itself. But the activity is just saying, go ahead and call this agent, do that work, and report back. As I mentioned before, the Durable Task Scheduler. This is I talked about this last month at the Lightning Talks. I'm a big fan of what Durable Task Scheduler can provide. If you're not familiar with it, DTS is a fully managed Azure service built on the Durable Task Framework, which works out great for Durable Functions because that's what Durable Functions is built on, right? The nice thing I like about DTS is it does give you this dashboard you see where I can see these are the orchestrations that I have running, and I can click into an individual orchestration and then see kind of where it's at from a process perspective. I can get sequence diagrams, history. I can then manage that orchestration from the dashboard, which is something you don't get out of the box with App Insights or if you're using Azure Storage. And I can run it locally with Aspire's container support, right? I can certainly provision it in Azure if I want, spin up that resource and just connect to it. But it does cost about $600 and some a month to run. So for me, I'm just going to run it on the container and let it spin up the container for me, which from the Aspire makes that a fantastic setup. So as a reminder, the scenario I'm going to walk through, right, is this insurance processing scenario where we get a claim. I got to check for completed data, make sure we got everything there, canonicalize it, so transform that, do some data manipulation and transform the shape of that. I want to look at a policy detail. In my case, it's going to be a markdown file that has their data in it. I want to go ahead and look that up to make sure it's covered. I'm going to use MCP to call an existing API to make sure that, to get all their past history so we can use that to check for potential fraud. If it's a high probability of fraud, we'll pause the workflow, and then somebody has to go ahead and resume that as well. So maybe there's someone in there goes, yep, this is legit, or we're going to stop it. And then I'm going to have another service going ahead and another agent that will go ahead and generate a communication for me. So maybe I want to send a notice to the customer via email or a text message. So I want this agent to go ahead and create all that for me, and then go ahead and save all this information down to maybe like Azure Storage so that a downstream system could pick that up and do some stuff with it. And this is just another view of that, just to kind of help visualize this a little bit differently. All right, we'll get an HTTP post that's going to start our workflows, and that post is going to have a JSON of a first notice of loss. That's going to be the first thing that the system receives is what our claim is about. That kicks off the durable function, which will start this claim orchestration. And there's 7 activities that'll get run. One is a completeness assessment. They'll call an agent to do that. The agent can pull up a JSON schema of what it's supposed to look like, what our claim is supposed to look like. And then the agent determines, based off that schema, is there any missing fields? So I'm not writing logic to check for fields. I'm just saying, here's your incoming JSON, here's your schema, compare the two, are there any missing fields, and report back. If everything is good, then we give it to the canonicalization agent to do the data transform, to reshape that JSON for us. Then that flows to, then there's a kind of a fan out here, right? So the first 2 are very serial, one flows to the next, and now I know I've got a good policy. It's going to be it's complete. We've transformed it. Now I want to fan out to 2 different agents, let them do their work on checking if it's covered. So I've got another tool that's set up to say, hey, go ahead, based off the policy ID you have, call a tool to go grab a document that defines what this policy is about, what vehicles they have, what exclusions they might have on that policy, and bring that information back and let the agent determine if, based off of their policy, if their claim is covered. And then also look at a fraud perspective. Go ahead and call my MCP tool, call my API, pull back all their history, and then determine, based on some rules that are written in the system prompt, is there a high probability that this is a fraudulent claim? Right, so I'm kind of using the orchestration framework and durable functions to say the output from one agent is the input to another agent. I'm kind of using the inputs and outputs of those agents to kind of coordinate the workflows. And I can fan them out. If they don't depend on each other, go fan out, wait for them all to complete, and then come back. And then I can do things like generating the communication, because I know now either your claim is covered or not, is a potentially fraudulent claim. So I can let my communications agent then generate the appropriate communications with some prompts I give it on kind of how to shape that message. And then I need to send that. And this becomes more of like, okay, just call the Azure Communication Service to send the email. And then I want to write some JSON structure down to Azure Blob Storage as kind of the history of what actions we took.
So what is
Yeah.
the tool? When you say tool versus MCP, what is a tool?
So a tool, or in Semantic Kernel calls it a plugin. A tool can be some native code that you want to run. So the Semantic Kernel has the idea of I give the tool a name and a description, and if the agents can, the LLM can determine, hey, I need more information. So then I call that tool. That tool returns back, some JSON structure or whatever. That gets bundled back in, and we'll see. I can show you the output, the request response to the model. And it can send that along with the request to the model, and then the model can use that additional context to make its decisions, to do its work. So it can be some native code that I run.
You can write code that Semantic Kernel can use. Like the agent basically has code that agents can run if needed.
Essentially.
Like functions that they can use.
Yeah, it's a function calling.
Yep. MCP can also have prompts and resources too. But yeah, tools are a big thing.
Yeah, Semantic Kernel views MCP tools as another plugin. Yeah, so if I've got an MCP endpoint, I can show you that here. Mine has one that says like, go get me all the past claims for a particular policy ID, and it just knows that, okay, well, I know the policy ID is a required parameter. Call this API with the policy ID you took out of the JSON, strips that out, and it goes, oh, now I've got this big list of claims that policy is submitted. Use that. The fraud agent uses that to determine, and your current claim, say, is there a probability based on some rules that I gave it, is this fraudulent or not? Good question, thank you. All right, let's try to walk through some of this. Excellent. All right, so this is our claim orchestrator. Remember, the orchestrator is the thing that controls the workflow, right, in our agentic workflow. So the first thing, I'm going to minimize this, move this over here, so hopefully it's a little bit easier to read. We get our claim that comes in, our first notice of loss claim. First thing I want to do is check. I'm going to walk through the sequence of events first, and I'll jump into some of these, right, just so you can kind of see the overall flow. I want to check to make sure it's complete. That's an activity function, right? If there's no missing fields, I probably should do something else in here, maybe send an email, maybe do something else. Right now, it's going to basically write a report down to storage, and that's what this finalize activity is going to do. It's like, hey, just generate, we didn't have all the fields we need, we're done and out. If we know we have all the fields, I'm going to canonicalize that so I get a form that I know the rest of my system is going to use. And then I want to fan out. So I'm going to fan out to the coverage task, this coverage activity, and the fraud activity. Those activity functions can go in parallel and do their thing. When they've all come back, I'm looking at then to see, is this a probability that there's a fraudulent? In my case, I'm saying if it's greater than 60%, if the agent determines that the chance of this being a fraudulent claim is more than 60%, I want to do some work. In this case, I put a wait for external event. So I could simulate, hey, it means I need to send an email, there has to be some other system, something has to happen. For demo purposes, for testing, I set to 5 minutes, it'll time out and then continue. But I can say, hey, now that I got this event that comes back, a fraud review completed, event that could return, I can go on. And then it's a matter of, now I've got all my different information back, I want to generate this claims analysis report, and I'm going to use that to send a communication. So I'm going to tell my communications agent, go ahead and generate me communications that are suitable for an SMS text message and an email as well. And I could add different messages in there, but the agent has some rules that it has on like how to generate those messages, and then send that using Azure Communication Service. Then when we're done, write all that stuff down to Azure Storage so that we can go ahead and archive that or use it for later purposes. So we can go ahead and look at a couple of these, and we'll jump in, say look at the completeness. That is not the field I wanted to click on. This is the field I wanted to look on. So this is the completeness activity. All these activities look very much the same. All they're going to be doing is calling that completeness agent. This agent is based on Semantic Kernel. It's got a base class. I'll jump into that in a minute. But you can see here, the constructor says that gives it the name of that agent, and then this is my system prompt, right? This is the thing that I'm telling it what I want it to do, right? It has to check the completeness of the claim. I want it to return back in a certain format. I want to make sure that it only gives me back strict JSON structure. That's the system prompt. And when it actually runs, it moves down here into this process async method. And this is the user message that it gives, right? I'm basically telling it, analyze this JSON for missing or inconsistent fields and produce the required JSON output. I did give it a little bit of a hint on what I wanted to do as far as that tool to call, because I noticed that sometimes it got it, sometimes it didn't call the tool I wanted, so I'm giving it at least a little hint, like call this tool to make sure you get your schema, and then I can go ahead and invoke that agent. Just so you can see what those tools look like. It's under plugins and schema tools. It can be something as simple as reading from a file, which is what this one is. Right? It's just going like, I know I have a schema down here that defines what are all the required fields that I have for this JSON document or for my claim. All I want the agent what this tool to do is go ahead and read that in. But it can be different things like, not that one, policy tools. This is one on getting policy details by ID. So it has a little bit more information on here of when it's supposed to call this tool, when it's not supposed to call this tool, and how does it work. And this is going ahead and looking for a particular samples policy. This would be where it pulls up the policy documents. This tool is like, okay, I've got a policy document. In this case is one that ChatGPT made for me. It has some information on it. It says, okay, well, based off your policy, what vehicles are covered by your policy, what are your coverages, your deductibles, that sort of stuff, any endorsements you might have, any notes. So I want the agent to be able to grab this whole thing for it to make its determination on what to do about this claim if it's covered. Where was I? Completeness activity, completeness agent. All right, so this base class here does some work around determining, where's the constructor we were on? This one here. So it sets some options and then kind of things on how I want JSON serialization to work. But then this is the chat completion agent we saw in the slides, right? Give it the instructions, the kernel to use, and then which service do I want to use. So I'm defining, I want to make sure you're using GPT 4.0 and JSON. And the reason I put the service ID in here is because when I spin up my function, I'm giving it a few different options to work with. So the Azure function, when it starts up, has information on where are my MCP tools? Where's my endpoint for MCP? So I've got an ASP.NET API that's running. I want to make sure it knows where that is at. And so I can call it as an MCP tool. And then I've got two different options for which models do I want to work with. Do I want to use GPT 4.1 or GPT 4.0, which is the deployment name that I passed in. So I can kind of control that in this way. And this is how you add in those MCP tools that you asked about. All right, it's like, as long as I know that endpoint, tell it to go ahead and grab those and list out all the tools that MCP server has. And then just add in additional tools around schema validation or policy tools as well. All right, so the agent can define things in code, like here my system prompt, but I can also do stuff, which one does it? That's a long one. Coverage. If I don't want to put all that into code, I can set up a template file as well. So I can get that stuff out of code and have it set up like a liquid template, so handlebars, whatever, YAML schema. I can put a template that says, okay, now put all my system prompt there. And that can look as simple as something like this, right? Where I take that code and say, okay, here is a template. This is the message that I wanted to have. It's a semantic kernel template. And I can give it the JSON schema of what that output should look like. So there's a couple different ways you can set up the templates. Like, so I like this part so I can kind of get it out of code as well, because else you can get into system prompts that look like this fraud one that can get a little long. This is where I'm giving it scoring guidelines, reasoning rules, step-by-step instructions, examples to work with. So it gets a lot into like, how do I want this agent to actually work? Any questions on any of that before I run through a couple of examples? Yeah.
Can you show the connection to the MCPs?
Yeah.
I guess.
Yeah. No problem. So this is this policy API project, and let me just jump into that. It is just a simple ASP.NET minimal API here. This is going to return some stuff about a claims policy. And I'm pretty sure all these are just hard-coded values it's going to return right now, right? But that is just a simple ASP.NET project that it's going to have. So when Aspire spins up, it makes sure that it spins up that project and gives a reference to that project here to my function project. But the main piece is I need the endpoint for this. And I should show one other thing. Now I think about it. Tools. This is the tool part, right? So it uses that same claim history service that the API uses, but I use the C# SDK for MCP. Say I'm having the MCP server tool type, put that attribute on this class, and then give it a description, a name and a description. And that's all I need to do to expose this as an MCP tool that can be used. So the same code that my API can use, I just put it in a service class that it can call. All right. So the app host then passes the endpoint to this API through this MCP server URL variable, environment variable.
Wait, did you say that the API just needs some attribute to make it an MCP API?
MCP is remote server, yeah. And that,
There's a one endpoint of the full API.
yeah, there's the regular REST API that ASP.NET exposes, and then there's the streaming HTTP endpoint for MCP would use. And to expose it, it is just the
It's like 2 lines.
yeah, it's add that, and that makes with the C# SDK. That's it. Now this MCP endpoint is not secured in any way. There probably you put some authentication on it.
Yes.
But this one is just running locally. I haven't deployed this to Azure. I have my next step slide is probably should put some off around this one. But to get it up and running to kind of play with it, these are all sitting just local right now.
And then how do you call this one? That
Yep.
be called from the durable function.
Yeah, so we pass in this environment variable, right? So that gets passed into my Azure function. And then function project. Thank you. The function project, it looks for that MCP server URL environment variable. So, okay, here's where your endpoint is. Create a new client transport, which is part of the C# SDK as well. Pull that in with my endpoint and auto detect streamable HTTP first, and then it falls back to what SSE server-side events, the kind of older format for MCP. And then create a client to that endpoint, and then list those tools out here. And then Semantic Kernel can pull it in with that line. So then I'm just saying add those plugins from functions, and just saying, hey, go ahead and grab me all those as kernel functions and put them into Semantic Kernel. So whatever if I would add more tools to that MCP endpoint, my code doesn't have to change, right? It'll just auto detect all that stuff.
So do you have to put into code like which function you're going to call from the MCP server, or do you let the agents decide?
That's all I have to do. Yeah.
If it's a tool, I'll verify it.
Yeah, I've noticed that it seems like it does better with more Python formatting for the tools. Like, where is it? Too many tabs open. Yeah, like kind of naming schema. It seems like it does better if it's like underscored, right? And then give it a nice description. I play around a little bit with giving the names and enough descriptions so that it kind of knows what to call.
But that might change if you change to a different model. Like its purpose is for naming, which is kind of sucks.
I switched around different models and it stopped calling my tools.
Yeah.
I'm like, or it went into a loop and just kept like spinning. I'm like, okay, I'm not gonna figure that out now. Go back till I know works and then figure out what the difference is with the models.
What's in the prompt? Do you give it a hint to use this tool or no?
Most of the time I don't have to give it a hint. There's that one I showed that it didn't call the schema tool consistently. I would run it sometimes and it worked, sometimes it didn't. So I put a line in the prompt that says, hey, you have access to this tool. And that seemed to kick it into like, all right.
Do all the agents have access to all the tools?
Yeah, if I gave it to the kernel, when I registered they're not registered to the individual agent, they're registered to the kernel, and the kernel is given to the agents. But the kernel has all the tools. All right. A good question, thank you.
You could have like an agent call the wrong tool, like if it somehow returns.
Yeah, you can give it maybe some in the prompt, like you only should call these tools, but I've been trying to let it invoke. I give it function callings, like you can do what you think is best. And I'm just kind of giving that, but I can kind of restrict it down. So you should just call this one, or whatever, or hints. But I turned on auto function calling, just like you call the tools that you think are best. And hopefully I've given a good enough description of when to call it and what it does and the problem that we have. So far for me, it seems like it's been working fairly well. Although sometimes I had to give it like a hint a couple times.
I think it's an interesting idea that because the language model, the comments that you're putting are weighting which tools it's likely to reach for because of the language of your prompt and the language of the comment. Each model is evaluating that weight differently and leaning towards tools that are commented correctly. So readability takes on a different tone. Here, it's readability to the LM instead of readable to my colleagues. So,
yeah, it's giving enough context, enough description that it goes, oh, I know what this is now.
Right.
And good names. It seems like a lot of the models are trained on Python. So it's giving it more Pythonic sort of naming. Okay, we can do that.
Naming is the hardest problem, so.
All right, let's go ahead and run a couple of good questions. Thank you. So we'll spin up my host again, because it controls everything for me. Which is why I love the Aspire setup here. Because I don't have to worry about spinning up the ASP.NET project and the dev and the containers and the function project. It's all set up. And you notice the pin on here, because I set these to be persistent, so I don't have to spin them up every time. They're going to stay online for me, so I don't have to wait for those containers to come up, which helps speed it up a little bit. I can go here, we'll spin up DTS. Is that big enough? Yeah. And I've got a few old ones that I've ran out here in the past. But let's see, let's go over here and we'll go to traces. So these are the ones that have started so far. And we'll let that sit there and we'll kick off a couple of these. Because I'm terrible at UI, we're going to send some JSON requests through. So this is what a valid first notice of loss would look like. It's got a claim, a policy, got who was hit, right? And so maybe some pictures that went with it. So if this, we'll go ahead and just run this guy and let it go to the completion. And so I get back the normal response that you would see. But I can see in here, all right, now the agent's kind of doing its work. I can kind of scroll up and look through these and see what the agent returned. On a few of them, the fraud agent said it's a 10% chance of fraud. So that's pretty good. This is the coverage models that looked at, pulled up our policy claim, looked at that. Here's all the information on our policy and our email. So I can actually go back to a better view and see now I've called the GPT-4o mini several times and the GPT-4.1 to do one of them. And I can jump in to this one. I can see it called our API. This is our MCP tool that we talked about just a minute ago. I get historical policy claims and I called that policy API. And know it needed to get policy details by ID. So it called that tool as well. It just looks up, pulls in that markdown file and uses that markdown file to analyze based off the current claim. Is this policy covered? Because I have the details in that markdown file. So I can jump into any one of these and kind of look through what did it call? That one didn't do anything. This one called communications service. Right here's this one. This one does our schema, called the schema tool. And I can look at these and see, and here at the spiral I like that there's my system message, our prompt for that completeness one we saw. So I want you to go ahead and do that. Our user message, this is that claim that we sent in. And we can go down and see it's saying, oh, I need to call a tool, and got the response back from that tool. Right? This is that JSON, the schema that we called. So it's calling that tool now, and then getting those responses back. So I can kind of jump in and see all the different stuff from what it sent to the prompts that were sent, which I really enjoy looking at. It's kind of fun to see. Right, so that one worked out fairly well, and if that one did what it was supposed to do, it should have sent me an email. And this one should be it. Yeah, 1 minute ago. So it sent me an email and said my claim was approved, and it showed me some information about that policy that we had. We can do other ones let's see, minimize some of these on here. So this is an uncovered vehicle. Right, so this guy, 1, 2, 3, 4, 5. Pull up his policy. All right, 1, 2, 3, 4, 5. He's covered for a 2020 Toyota Camry on there, but he sent in a claim for a 2025 Lamborghini Aventador. And he hit a telephone pole while delivering Jimmy John's. So that's probably not a good thing. Stinks for that guy messing up his Lambo. But we'll go back into here, look at our traces again. So that's where we ended before, right? As a claim policy not exist. And this guy, now it's running through that whole process again, calling different models, using the models that are passing so I can override which model I want. And for me, I chose to use 4.0 mini for most of the stuff and then 4.1 for the communications. And it dropped all that in. If I go into Azure Storage here and my claims, it should drop down a couple of reports. I don't know what claim was that, I forget. 4, 5, 6, 7, 8. So there's claim 4, 5, 6, 7, 8. And I got my reports in here. If I go look at, I should have got an email about this guy too. I'll say my claim's not covered, so we'll refresh this and see if that showed up. Yeah, so it said, yep, you submitted your claim for your Lamborghini. Based off your policy coverage, it does not apply for commercial coverage. So it's not covered. And it gives it a phone number and a link to our website. I'll go back. So it can control all that information. We can do one more. That's I think show the weighting if we want. So this is the policy one. This is an invalid one. So this one I think is kind of nice. So I can look at the invalid results from it. So this one's missing some data, right? It doesn't have a policy ID on it. So I can't look it up. And it's missing a few other things. We'll run this one. We'll just scan through the code results so we can kind of see what's missing. The console log, because that's fun to look at. Yeah, so there's our agent response here on what it returned back, right? So based off the schema, we know that we're missing a policy ID and a location and some questions that I could say, like maybe there's some tool or whatever that could be asked that the agent thinks that you should ask to fill in this information. So this one's kind of done. Because it just stops right there, like it's missing incomplete, missing fields, I quit, right? That's what the orchestrator was told to do, so it stops right there. Any questions on any of that or something else you want to look at in the code?
We're going to show the scheduler. You said there's
Yeah, good call. Thank you. Yeah. So I can look at all these. There's 3 there. Now I've got more that run, and let's look at this one. I can see in here, these are all the different activities that ran, how long they took. I can see more of a history view, jumping into them if I want to see the state at any time. I can see the state at that particular time, right? And if I want to see a sequence diagram of how this flowed, I can do that as well and jump in and say, okay, they occurred kind of sequentially, and then these 2 here went kind of in parallel. They were kicked off at the exact same time. And then I had some more sequential ones that popped in after that as well. So this gives me a nice view to kind of see where things are at. If I want, I can kick off another one that kind of shows the high probability of fraud example. This one will go and it'll stop and wait for me now, right? Because it does. The agent's kind of determining, there's a high chance that this is a fraudulent claim. Yeah, so it's 62% chance this is a fraudulent claim. So now it's waiting for me to do something. If I jump over and look here at the orchestrator, this one is it this one? Yeah, it's running and it's kind of stuck. It's on a timer trigger now for 5 minutes. It'll sit there and essentially wait for something to occur. So I'm going to go ahead and kick that through by just telling it, giving it an event, this fraud review completed event, to go ahead and start up again. So I don't want to wait 5 minutes for it to finish. So I can go into here and say, all right, fraud review completed, sure. And now it's going to start running the other pieces in the workflow that were set up, right? So it's figured out the communications, agent did its thing, and now it's working on sending with Azure Communication Service, and it's now done, right? So if I go back over here, see if I got a new email. This one should say something to the fact that we got to look at more information because we think it's fraudulent. Yeah, so it pulled in its claimed information, but I gave the agent instructions that if we think it's fraudulent, don't tell the customer we think it's fraudulent. Tell them we need more time to review. So it looked at that and figured that out and put that in place. Yes?
Yeah, so there's you know, the response schema, like the confidence. Have you done any like sampling, like done the same play over and over? Is it probable to change?
I've been using these same 4. Where's my HTTP file? These same 4 examples on what I've been working on so far, and it is almost always 62%. Now, some of that is when I gave it the fraud. Where's my fraud agent? The fraud agent, I'm going to minimize this for a minute. Like, it has some rules in here about how I want it to score.
Would you do on production some kind of sampling and you're combining several?
I would probably do more of an evaluation of saying like which models produce the best results, consistency of the models based off the variety of data that I have, to see which model is cheapest to run, best results. I'm in there, giving it different criteria, and using maybe something like Azure AI Foundry or something to evaluate a wider set of data than what I've done so far.
I was going to ask about if you can use any open weight models or maybe OpenAI.
With Semantic Kernel, you can use pretty much any of the models you can get access to, whether it's Azure OpenAI, Hugging Face, Grok, whatever. Semantic Kernel doesn't care.
I probably would expect in real life, this guy would be using a commoditized agent with grounded data, and they'd be tuned to the workflow so that you could run your tests and compare it. You probably already have a predictive modeler for an insurance company. You're trying so you can compare it to that, and you can compare it to human, and then you can take that data and feed it back into the model, into the engine, and get what's more consistent. But you also, your error handling for here is going to be much lower. A human might say 75%, we're going to kick it out. Here it's 60%.
That's what I coded, yeah.
60%, we would kick it out. We would have a lower threshold probably for automation for a while until we get the data out of it.
And the email you put a thumbs up, thumbs down.
I could do that. Yeah, I had one before that was, had the template giving it like emoticons and stuff in there, and
It's definitely fraud.
yeah. The biggest variability I've seen on is the email, because I think it's kind of creative, so it fluxes a lot. But it does have certain rules about I need you to include the phone number, I need you to include the email address or the website. Something about if it's fraudulent, don't tell them it's fraudulent, tell them we need more information. Always include something about their vehicles. There's some like always in there, but the rest of the text varies from time to time because the agent's kind of has a lot of creativity in what it determines.
How does this handle edge cases? For example, let's say 2 parties, one guy says he's not clearly at fault, he offers to pay for damages by an insurance company, but then the other guy thinks, oh well, I also have damages in another part of the car, and he says, well, his damage that he was liable for, and my own damage that I had no evidence in what that person was liable for, is also going to be, he says he's also going to go. So how do you handle cases like that? Speaking from experience.
Yeah. Off the top of my head, that might be a case where the human still becomes a factor. Like in this case, the scenario I was exploring was like, could I get through the easy cases quickly, right? Things that are like, we know how this is going to work. It's a pretty easy case. Maybe the agent could say like, based off of the criteria in your example is, it's hard to figure out. I need a human. So maybe that human in the loop still becomes an important part. Like the agent's like, I'm not confident in my answer. Kick it over here to maybe another queue or another system. Like now I can have specialists go, okay, I can see the pictures. I can read the police reports. I need to make some phone calls. We don't have all the data. It could be something like that, where maybe the agents do a lot of the easy stuff to kind of reduce that backlog. And then now I have my people that are trained in that area that know it very well. They can do the harder ones and removes kind of the cruft. Let the agent do that stuff.
What about false positives, false negatives?
What about them?
Like how would you be able to detect them?
Potentially, maybe that'd be something I want to run through on that kind of evaluation models that we talked about. Right? I have an evaluation based off those criteria that come in. Am my prompts handling it correctly? Do I have the right prompts, the right models? How much reasoning goes into place? I want to use a more of a reasoning model like GPT-5. Can it give me better results and some of that stuff if it gets more complicated? Maybe that evaluation approach would be important as you get into a more production level system and seeing how it works. Yeah. All right, good questions. Thank you. I want to stop this guy from running and then finish up. Let's see. All right.
How long did it take you to make
A while.
it?
A lot of it, some of the claims information, like the policy documents, and some of the instructions for the prompts, it was me and GPT-5 sitting down and going like, I need a policy document that has this information. And I'm like, yeah, that seems like it looks cool. I will do that. So I didn't want to like go through and generate a whole bunch of it. So I was like, just do this for me, and then tweaked a few things in there. Some of the system prompts were Copilot and me working through some stuff, get a Copilot and going, I need a little bit more, or that's crazy, and then tweaking it from there.
Would you say you're pretty familiar with the APIs around the semantic kernel and Aspire and stuff, or like, was it fun to learn, easy to get into, or what was the curve there for picking all this stuff up?
I'm very familiar with durable functions and functions. That was very easy. Aspire was not so hard, right? It's pretty well documented, I think, at this point. The local developer experience is pretty easy. I think the client integrations, the deployment pipelines are a little bit harder. I think if I wanted to publish to Azure and getting, how do I want it to do that? It was a little bit harder. Do I want it to generate bicep, or do I want it to do that or not?
Mm-hmm.
But it's still pretty good, I think. Semantic kernel is probably the hardest thing, honestly, for me. It's changing a lot. The documentation is incomplete in a lot of areas, and it's a lot of splunking through the GitHub repo. For me, it was. I've gone through and like finding their samples.
And they change all the time too.
The documentation is like coming soon in a lot of areas. So the GitHub repo was a big help. They're active on Discord. They have weekly office hours that I've been attending and asking them questions on there when the docs don't cover it. Like I registered 2 models and I couldn't find in the docs how it determines which one it picks.
Yeah, the service selection stuff takes a little bit of
I was like, it doesn't tell me. And I was like, I think it's last. Last one in wins, I think. So I asked on the office hours, and they're like, they pointed me at the code and like, it's here. And I'm like, oh, it is last one in wins. Okay. It's like, so that's been helpful, but they're switching from Semantic Kernel 1 to Semantic Kernel 2 in a couple weeks, probably. And that's going to be the autogen, merge of autogen into Semantic Kernel. So I imagine the API surface is going to change completely.
I had a related question. You're doing a lot of things with fan and fan out, like durable functions. It's really built for that. The tooling's good for that. I'm curious if you looked at all that process framework stuff coming to Semantic Kernel.
I saw that and I haven't looked at that. I saw it like listed as like experimental or preview.
No, very, very experimental.
Yeah, even their agent, maybe I don't know if that one's GA'd yet or not.
Yeah.
But I saw they're doing the process and I'm like, this looks very similar. Right. And I imagine that one will change quite a bit too especially as they roll in some of the autogen features, because it had a lot of that sort of stuff.
Yeah, I've been experimenting with that for my D&D thing. I'm like, ooh, yeah, your durable stuff is getting you some really nice UI stuff that's kind of built for it. That makes a lot of sense. Yeah.
That's one of the things I like about it. Like some of the tooling, like durable, some of the stuff is out there, been around for a long time. Yeah. It's known, it's proven, it works. And I'm really excited to I just need to have the agents call each other or talk. A is an option, still new, but if I can get output from one agent and I can pass it via code to like another agent, it's like, hey, you get JSON out and JSON in. Maybe that works out pretty well. They're not in this case, they're not distributed, right? I don't have them running all over the place, so it works. If I had them more distributed, maybe I need something like A or more of an event-driven system to make that work. Cool, thank you. All right. So next steps for me, one is I need a better UI. Something better than sending HTTP requests around. That might be a vibe coding weekend sort of thing. It'll give me a quick, UI to make this look a little bit better. I want to play more with error scenarios. I want to, try to do some stuff on having it fail and suspend or terminate workflows and then resume and pick them back up again, because I have that state persistence in place with the workflow durable functions. I feel like that's pretty easy to do. We talked about evaluating additional models. I've been playing with GPT 4.0 mini and GPT 4.1. I know, so like we talked about, if I change models, sometimes things go haywire. And there's like, is it my prompt? What am I doing? How do I support different models? Do I want to have that sort of flexibility? So playing it with additional models. Azure AI Foundry has agent capabilities as well. Semantic Kernel supports that through the Azure AI agent type. So maybe I could have a chat completion agent in Semantic Kernel and then kick it over to Azure AI Foundry for it to run kind of a hosted agent. mix that in together. Obviously put some better security around it, observability, and then get it all deployed to Azure would be kind of my next steps. So just to recap, I think with agentic workflows, having something like durable functions that I have that reliability and control in code is a really comfortable spot to work in, especially for non-deterministic things like AI agents. I get some determinism, with durable functions and that coordination there. For local dev time, Aspire is fantastic to spin up when I've got a multi-project solution. Aspire makes it very, very easy to work with. Semantic Kernel we talked about, I think, a bunch on. It's great for enterprise-grade AI stuff, but it is new and moving fast, so my advice is stay on top of it, and those office hours have been really good. Durable functions we talked about as an orchestrator, great for invoking the different agents, and DTS to see what's going on. That visibility is the biggest thing I like about DTS. That sequence diagram is great. I'll make the slides available. These are some resources I found to be helpful, right? That Anthropic blog and Chris Gillam's blog on building, using durable functions for building workflows is great. Links here to Semantic Kernel and the C# SDK for MCP. I'll put all the code up on my GitHub repo as well. There's a PR I need to make tonight to move all the latest code into the main branch there. And with that, that's all I got. Thank you very much. I appreciate that. This was a ton of fun. You can get the QR code. That'll link you to all my stuff, and then all the socials are there. But thank you. Any other questions or anything I can help with?
That's super cool.
Yeah.
Why did you decide to make this project? What was the inspiration?
A little bit of learning, and I needed to talk it for user groups and conferences, and this was an idea to work with.
You submitted this to CodeMaster, I hope, right?
Not yet. Submitted to CodeMaster? Yeah, it's on my list for the 31st, so I got it tonight and tomorrow.
Yeah.
Yep.
Yeah. You don't want them to accept me, submit that.
Oh, that's awesome.
Oh, thank you. It was a ton of fun to work with. I had a version of it at the Azure user group a few weeks ago, and then I rewrote a lot of it after that. And so I don't like how this is working.
Yeah. I was asking about your experience because I was thinking with stuff that's this new, working at an insurance company myself, we're kind of allergic to rapidly changing APIs, causing churn and then maintenance, and then our turnaround on projects for maintenance of that is like weeks, so then it's a big deal. But so it's hard to convince people to adopt something like Semantic Kernel where it's unstable. But
yeah,
it would be cool.
I've enjoyed the Semantic Kernel office hours. They offer them, I think today's Thursday, Tuesdays. I think they run them at Tuesdays or Wednesdays twice a day, depending on the time zones. And they've got the product team is on it. So you can ask them all sorts of questions about, and they'll tell you some roadmap stuff. Someone's waiting for an event for marketing to do what Microsoft Marketing does. But then you can ask them questions, dive into code, give them your scenario. They can give you some information. I think that's a fun, right? Because you can talk to them. It's like, here's what I'm trying to do. How do I do this with your tool?
Right.
Right.
So it looks like being able to see the inputs, outputs, and how all this stuff is chained together is a big part of understanding how everything's flowing through the system, right? Are you starting to get a sense for what size chunks to make when you're designing stuff like this?
A little bit. That's one of the things I want to do some more of. I think some of my prompts are maybe a little long. I want to see how small can I get them to get that token count down. I started off a little verbose to see, okay, this seems like it's working, and then what can I take out before it starts failing on there. But yeah, I want to kind of tweak that a little bit and see which models too are in there.
Do you think there's a different granularity when you're trying to understand if you've got it right versus when you want to scale it up?
Probably right. If I'm trying to scale it, I probably want to get the token count down just to keep cost down. But right now, I'm not as worried about it. It's not costing me a lot right now to run it, right? But I want to get it working and then start paring it down and tuning it after that. Getting the JSON output, that was a struggle. I went round and around on the inconsistencies that I want you to return JSON, and it would return JSON and then return backticks with JSON Markdown. Like, nope.
It's actually easier
So
to
close.
use Microsoft Extensions AI for that than Semantic Kernel. It's really interesting.
Yeah, like I had better luck by telling it to do JSON. What is it? Response format equals JSON output or JSON object or whatever. Some of the doc is like, well, you should be able to say return a type of an object, like give it a POCO, and it should return. I'm like, I did that, and then the model just went like in loops, and I was like, I must be doing something wrong because I could not get that to work one night, and I think I quit. I'm going back to telling it to return JSON output as a string. I'm like, I want it to be more strongly typed. I'm like, I'm not sure what I did wrong. Maybe it's my prompt, but it just went like forever and never ended. I'm like, okay, I'm not sure what you're doing, but I'm gonna stop you now. Yeah, so going back, there's a lot of like iteration, like why is it doing what it's doing? So having the Aspire dashboard and the OTel hooked up was helpful because then I could look and say, it just keeps calling the tool over and over and over and over and over and over and over again. Like, I don't know why are you doing that? And I was like, okay, tweak the prompt. I'm like, no, okay, sure. So having the observability, I think, is super valuable to see what it's doing.
Yeah, I do think with LLMs, like even if you just use GitHub Copilot in a big code base, one of the biggest problems is getting the right part of things in the context. So like if you've got a lot of tools available or you have a lot of things that it's thinking about, it might grab the wrong thing and then it gets into a situation where it's not thinking through the right stuff because it doesn't have it actually in context. And I don't have a solution for like, how do you point it at the right thing? That's why I was talking about the types of comments you're putting on things and like the language, the consistency of naming and stuff like that. It all helps get the LLM to reach for the right part of your code. But yeah, it's a tough problem.
So when Donovan, Michael and I work together, we got a guy that all he does is bulk agent workflow. That's kind of what he's building out the whole platform. He's saying when he defines an agent, he says, hi, you're an agent, you're this is what you do. This is the scope of what you do, and these are the tools in which you have available for you to use it. So he scopes the tools. He says, use these tools. But he doesn't say don't use other tools, but he says specifically, here's the 3 tools that you might use to solve that problem. I know you were trying to avoid that route, but you did it when you had to. But if he's defaulted, that's just kind of how he does it. He essentially says, hey, you're a thing. Here's your hammer. Here's your screwdriver. And here's your tape measure.
Yeah, and even for developer stuff, you see like claude.md files or agents.md files where for your repository you specify, this is the compiler I'm using and use this command to build, because otherwise it will do some kind of default build command and totally fail.
I do it. I give it instruction files. Like I got these GitHub instruction files for GitHub Copilot that based off of whatever I'm asking it to do. Like I want certain things for like C# files, right, or ASP.NET or code commenting. Or I give it some instructions in that file to work with. General Copilot instructions about my code structure, right, what it looks like. Cool. Well, thank you very much. This was fun.
Great, thank you. That's all we got. Grab some pizza.
Yeah,